Hello everyone. Today we will do some practical example of hierarchical clustering. Now, if you're following my channel, probably you have seen that I have already tried to explain the hierarchical clustering, how it works, how it relates to dendrograms. Still, let me just give a little bit of brief about this and then we'll start the practical implementation. Hierarchical clustering is an unsupervised machine learning algorithm. And I think by the time you all are aware what is unsupervised machine learning, where you do not have a labeled data and you have only the features, and based on that you have to basically group. And this clustering methods are basically your grouping, that probably you have 100 records or 100 observations. Out of that, probably 30 observations are in a similar group, 30 observations in a similar group, and remaining 40 in a similar group. So you're basically grouping or clustering into different things. It is called hierarchical clustering because it creates a hierarchy of cluster which can be represented on a tree diagram called dendrogram. In my last video, I showed how basically under the hood this algorithm is creating the dendrogram, and then based on the threshold value, it's creating the number of clusters. High level, the algorithm is very simple. At the start, each individual object is considering as a single cluster, and then it's finding the distance. The algorithm then merge the two clusters that are close to each other, and here we have to check different kind of a linkage, choose the distance matrix, reduce the total number of clusters by 1. Iterative process, and this step process will continue. Now, there are two main types of hierarchical clustering, and in my last video actually we covered this one. We have not yet covered this one. So in my practical example also, we'll focus on this agglomerative hierarchical clustering approach, which is a bottom-up approach. And what is this bottom-up approach? In this approach, we start the individual objects, each consider a single cluster. In my last video, I mentioned that we have data points and each data point is a cluster. Then we'll basically try to find out what is the minimum distance between those 2 points, and then we'll take those 2 points and create a cluster. And then again, we'll continue the steps. So that's basically the overall process. Hopefully, if you are not familiar, I'll provide the link. You can just check that particular session. It will be clear. Hierarchical clustering is very popular in unsupervised machine learning world. And the key feature of hierarchical clustering is that does not require or use a specific number of cluster in advance, which unlike many other clustering algorithms such as k-means. So this is one of the big advantage, that you don't need to specify. But though in our example, we'll specify because I'll show you like why we're mentioning. But this is the biggest advantage. Again, I mentioned the hierarchical clustering can be applied in many areas like recommendation engine, anomaly detection, natural language processing, all these fields. So again, this is important point. It's important to note that hierarchical clustering can be sensitive to the choice of distance matrix and can be computationally expensive for a large dataset because it has each iteration distance needs to be computed between each pair of clusters. So remember this thing cannot be undone. So this is another point just for your note. Okay, let's jump in. So right now, basically, I'll take inbuilt datasets, which is the breast cancer datasets, and this data actually has two parts. Let me delete this line. This data has two parts. One is the data part, another is the target part. So when we are working with the hierarchical clustering, ideally, we will not have this target component. We will have only this data part. So basically, we will have this 30 columns, and based on 30 columns and number of observation, and based on this, we have to group it into different category. Now here, we know that we have two categories, that is malignant and benign. That's why you will see that when I build this cluster, I mention specifically that give me two clusters. Otherwise, you can leave it and let the um, algorithm decide how many clusters it can form. Okay. This is the level data, which actually will not be present in the real work. But in our case, we keeping this level data because it will help us to kind of identify how the model is working, how the accuracy is coming out. That's why. Otherwise, in the real world, you will not have this information. Very clear. So this is an unsupervised machine learning approach. You will have only this component. You will not have this component. Remember this very carefully. We have the data part, and now what we are doing basically simply we are calling sklearn clusters to this agglomerative clustering, which is we are bringing this model, and right now it's just a default we are calling it. That's all. Few other package which we need, we're calling that thing, and then I don't need this. Need this with the model with the cluster. So basically, this code, if you run, and I'll provide this code, you can run this code as it is because I'm using a default data set. So if you struggle anywhere, if it's not running anywhere, just let me know. We can work together. So what we're doing, basically, we are mentioning here number of clusters and we are passing this linkage and affiliation. Okay. So this is important thing. Just you do a shift tab, you will able to see this informations that by default it is creating two clusters, and in our case we know we are looking for two clusters. That's why we're providing this information. Okay, by default it's two, and if you do not provide the number of clusters to find, it must be none if threshold is not null. What does it mean? If this is not null, then you have to definitely mention. If it is null, then you have to mention it. Otherwise, you have to pass the distance threshold. Affinity is different kinds of affinity, or distance metrics are there, Euclidean distance metrics are there. Remember this thing in my previous video, I mentioned this thing, like if you have a large sparse matrix, Euclidean distance is not a right approach. You should always use some different kind of approach like cosine or precomputed or some kind of a dot product. Okay, and then I think the main important thing is the linkage. I mentioned clearly in the last videos, like this is another, based on your linkage, your result will change also, right? And that's why it's important to do kind of hyperparameter tuning. Like these are all kind of hyperparameters, right? You are not sure which one will work best for your model or for your data. So it's kind of doing a grid search CV, but in this case, we'll not use the grid search CV. We'll just use the looping method. And I believe at this moment you have some idea what is complete. Complete mean that when you are measuring the distance between two cluster, you always take the max length, right? And then complete is that one. Single is exactly opposite. Average is just average of mean and max. Word where your variance is less. And there was one more which I mentioned. I'm not sure why it's not mentioning here. The default is word. That is centroid approach. Probably now centroid approach is probably not available. That was probably, I just took it from the old version. Okay. Yep, I think that's all. So now you will basically just take your data and pass. So once you build the model, and you will build it with the default values like affinity and linkage, and then you'll pass the data, and your it will basically your labels will be done. Okay, and if you just print it, so you will get the label. So basically your first observation has been denoted as 1, second observation is 1, third is 1. So that you can now group those data. Okay, whatever is 1, put it into one group, whatever is 0, and put it into different group. That's the basic fundamental concept of the clustering, that okay, I have these observations, these 500 observations, but now my model is saying that, okay, these 300 records or 400 records are actually similar and use for different kind of work, and this another record is a different kind of work. Okay, so this is very crucial. Okay, and now the important part, like how when you have some kind of label data, in our case we have some kind of target values, so we can check the performance of the model, right? So for that, one thing you have to remember that um, when you are doing the clustering, it's not giving you the exact leveling. It's randomly choosing, right? It's not like, so that's not 1 and 0 always the way it's actually on your actual observations. So that's why what you have to do, we have to write some kind of a function which will basically check the permutation. Like, okay, if you have two values, whether 0, 1 is giving me the exact accuracy, or more accuracy, or 0 1 or 1 0 combination is giving me the more accuracy. Okay, I'll just remove this part because this is not needed. Okay, so what will happen, it will basically this function will create the permutation combinations, and I don't need this also because you can just uncomment it and run it, and for just to understand how this code is working. But ultimately, if you just run it, oops, I think, let me just run from the top. Um, Give me 1 minute. Okay, so we got the result. Yeah. Um, Probably I didn't run all the code, that's why. So it will give me this accuracy. Now remember, this is one crucial thing, like when you work on hierarchical clustering, if you completely do not have any label output, it is very difficult to check the accuracy. You have to rely on your model output actually. But in this case, because we have some leveled output, so that's why we found out our model accuracy. And at the same time, you can plot it, and this will give you the result. Okay, and this part I will comment it out, you don't need it because I just tested. Okay, if I because in this case what happened that I use 1 0 combination, but I thought, okay, let me check if 0 1 combination what values are coming. So that's why I checked it, but you don't need it at all, so you can just skip this part. Now basically the important part which I was mentioning, that a lot of time it will be very hard to define like what will be my correct linkage method and what is my distance matrix. So that's why what we have to do, we have to pass this multiple values, and we have to basically kind of doing the grid search CV kind of thing. Basically run multiple models and find out which parameter is the best parameter for my data and create that model. So exactly this piece of code will do the same thing. It will just run in a loop and use these multiple combinations and check, create the model, check the accuracy, and all those things. So it's basically just doing like this. It's linkage this, distance this, what is my accuracy, confusion matrix. Same thing, some of the combinations are not allowed. So word with this combinations are not allowed. So we are just bypassing those things, but all other combinations we are testing. And finally, we are checking, okay, this is my best model. And for that, I should use the word, and distance is the Euclidean. and it is giving me this best accuracy. Okay, hopefully you understand the hierarchical clustering concepts and how to use it for practical purpose. Now I will give one assignment which you can just use the same kind of code but use the different data. So this data is actually coming from gene expression cancer RNA sequence data sets. I've already downloaded this data and put it into data file and level file, so you can just use it. So just for your reference that I downloaded it, and I'll give it into my GitHub locations. Instead of just RNA, probably you can directly use it, or whatever path you mentioned this thing. I think by the time you know the Python part, so just put that correct path actually. Any problem, let me know, we can help you. And then just to show that here we have 5 different levels. So that's mean when you build the cluster, um, where I gave actually the number of cluster was 2. In your case, the only change will be number of clusters should be 5. Try with 5 and check how you're getting the good accuracy and what is your result is coming. So this is your assignment. If you stuck here, in my next video, actually my plan is to provide the solution for this assignment. Okay. Thank you. Any questions, ping me, email me, mention in the comment sections. We can learn together, grow together. Thank you so much. Have a nice day, blessed day. See you in the next video.